Hello guys, welcome back to my channel. Today I will be discussing first two problems of today's CODECHEF Starter Contest 97 Division 2. So first I will be talking about the first problem, that was Schrodinger's Smiley. So this was a pretty straightforward problem. So let's understand the problem statement first, then I will talk about its logic, then I will explain the code. So this was a basically simple implementation based problem. So we have defined Smiley if consecutive numbers of right parentheses are present between two semicolons, right? And we have to count the number of substring that are Schrodinger's smileys. So let me explain its logic first. So what I will be doing is I will be storing all the indices where semicolons are present. Let's suppose this is our string. Let's suppose this is our string. So first I will store all the indices where semicolons are present. Sorry, it's colon, not semicolon. So I will store all the indices where colon are present. So for example, here it is 0th index, 4th index, 8th index, 11th index, right? Now for a substring to be a valid smiley, the number of elements between any two consecutive semicolons should be exactly equal to the number of right parentheses. So for example, between 0 and 4, how many elements are there? 3. So all 3 should be right parentheses. Similarly, 4 to 8, all should be, how many elements between 4 to 8? 3. So for a valid smiley, all 3 should be right parentheses, right? But this will be not a valid smiley because all 2 are not right parentheses. So this was a simple. So now I will explain the code. Yeah, so this is the code. Yeah, so I have taken first, if n is equal to 1, obviously answer will be 0 because for a smiley to be valid, at least 3 elements must be present. Also, if n is equal to 2, see out 0. Now in else case, I have initialized counter variable as 0 that will store the answer. Now as I have said, I have stored all the positions of columns in a vector v. Now if the size of vector v is 0, what does it means? It means we have only one, we have no any column in the string, so obviously answer will be 0. Also if the size is 1, answer will be 0 because at least 2 semicolons should be there. Now in else case, I have iterated through the vector, and d is the number of elements between the two columns, and I have initialized a variable cn. Now I will iterate through every value between vi minus 1 plus 1 to vi, and if it is equal to right parenthesis, then I will increase the counter, and if counter is equal to d, as I have said, so answer will, we will increment the answer counter plus plus, and at last we will simply output count. So this was the first problem. I found it pretty simple, and now I will be discussing about second problem titled as triplets minimum. So it was a good problem as it involved a good understanding of binary search, prefix sum, and much more. So let me explain the logic behind this problem, then I will explain the code. So first, understand the problem statement in brief. So we have given an integer a of size n, cool, And triplet array is defined as the collection of minimum ai, aj, ak for all triplets, blah blah blah. You are given q queries for the following type. Yeah, so basically we are given q queries, and in each queries we are given a integer k, and we have to return the kth smallest element in the triplet array. Fine, so it is pretty much clear that we can't use two for loops here because constant are large, n and q are around 10 to the power 5. So from here we have got an idea of binary search. Also we can use n log n, right? So that is pretty obvious that we have to use binary search. Now let's understand its logic first. So let's suppose we have an array 2 3 1 5 7. So we have n is equal to 5. So let's forget about the queries first, and let's understand its logic behind this problem. Now let me sort this array. So this is the sorted array, right? Now if I ask you, in how many triplets one will be minimum, what will be your answer? So let's think. So I have fixed I as 1. Now we have to choose j and k from these elements because this should be valid, right? So what I will do is I have to choose 2 elements from these 4 elements. So how many ways are there? So there are 4c2 ways, that is 6. So in 6 triplets one will be minimum. 3 5 6, right? Now similarly, in how many triplets 2 will be minimum? So again I will see right side of the 2, and I will again choose 2 elements from 3. So it is 3c2, that is 3. So in 3 triplets 2 will be the minimum. Cool enough. Now in how many triplets 5 will be the minimum? So obviously 0. Why? Because we don't have 2 elements from right of 5. We can't choose j and k. So now if I'll ask you what is the let me explain again. So now if I ask you, so basically we have, let's say we have 5 queries. Now in first query I ask you the first smallest. So what is the first smallest? 1, second smallest 1, third smallest 1, fourth 1, fifth 1, sixth 1, so on. 7th is 2, 8th is 2, 9th is 2. So how can we quickly, in O of 1 or O of log of n, we can give answer in each query? So yeah, we can give answer in log of n in each query by using binary search. How? So if I say, yeah, so 1 is how many times? 6 times. So first I will write 1, it is 6 times. 2, how many times? 2, 2 is 3 times. Let's say it is vector v2, and I have stored these in vector v1. Now let's define a vector v3 as prefix sum. So prefix sum, so prefix sum of vector 2, so it will be 6 and 9. Now if I ask you, tell me the 7th minimum value, 7th smallest value. So what will be the 7th smallest value? For that you can just apply a lower bound on this prefix sum array, as it is already sorted. So the lower bound of 7 is 9, so 9th correspond to 2, so answer will be 2. If I ask you the 4th smallest element, the lower bound of 4 is 6, and 6 is the first index, and first index we have 1, so answer will be 1. So that was the idea behind this question. I hope you understood it well. Simply in each query we are using lower bound to get the kth smallest value, right? So now I will explain you the code. So code is pretty much simple after you understand the logic. Yeah, so this is the code. I have taken input n and q, then I have taken a array, and then I have sorted the array. The 101th line has no use, map. I didn't use it. So now I have defined three vector v1, v2, v3, right? Now I will iterate through each value of the given array, given sorted array. Now if the number of elements right to it is greater than equal to 2, so n minus I minus 1 is the number of elements exactly right to the taken element, i.e. the ith element, right? So if n minus 1 minus I is greater than equal to 2, so what I will do, I will just push back ai to v1. So and in v2 I will push back a number of elements right from it, choose 2. So that will be basically p into p minus 1 upon 2, right? Now v3 is the prefix sum array. So I have in this for loop I have calculated the prefix sum. So v3 is the prefix sum vector. Now in each query I am taking the so in each query I am taking a value x, and then applying lower bound on x and getting its index, right? So by subtracting v3 dot begin I am getting its index and simply outputting v1 of tf. So that was the code. I hope you understood the problem and the code. If you like this video, please subscribe. Thank you.